Good morning, everybody, and welcome to 12.1. This is trying something a little bit different today. I'm doing a whiteboard lesson instead. I think you'll like it. Okay, so in section 12.1, and I'll get my hand out of the way with the shadows, it's all about tangent lines. And you know that a tangent, a little review of circles real quick. There's your radius, of course. But did you know that every single time that a tangent line, and a tangent line by definition is a line that touches a circle at just one point. And the rule for today is that anytime a tangent line touches a circle, it actually makes a right angle with the radius of the circle, which actually kind of makes sense. I'm going to work on my lighting here a little bit, which actually kind of makes sense. Because if you think about like this is a car tire on the ground, and the center of the wheel would probably look like it would make a right angle with the ground as it's rolling along. That would make sense. So every single time you ever have a tangent line touching a circle, you know that that is a right angle. What the good news about that is we know right angles have a lot of things to do with us in geometry, like right triangle trig and Pythagorean theorem and all that kind of stuff. So very simply, the first type of question you're going to see is if you have a circle something like this, and you have two tangents coming off of it. On Wednesday, we're going to learn that if you have two tangents coming off of the same point, these are called common tangents. If both of these tangents are coming off of the same point, they're actually congruent to each other, which is really, really nice. We'll talk more about that as we go along. But the cool thing is, if we've got this, and let's say this angle out here is like, I don't know, 30 degrees. And they're going to say, hey, find out what angle X is. And because we know, obviously all radii of a circle are congruent, but because we know that whenever a tangent touches a circle, it makes a 90. Doesn't look great. We say, oh, look, that's actually a quadrilateral. There's a couple different ways you could do this. So since it's a quadrilateral, quadrilaterals add up to 360. And there's my 180 already. And there's another 180, so it's got to be 150. Or you could split this down the middle and realize that these are two congruent right triangles. And that's 15, 75, 90. And 75 and 75 is 150. Well, regardless, either way, you're going to get 150 degrees, which is really, really great. So all sorts of questions about things like that. There will be questions like, oh, look at this circle, and this is the diameter, and this is a tangent segment, and I've got this interesting looking, now that's not a tangent, obviously. That's called a secant. We'll talk about that one soon. But they'll say something like, hey, this angle up here is, I don't know, 51 degrees. And say, what is X? Well, since I only know one of my three angles, well, actually I don't, because if they identify this as a tangent, well then, of course, this is going to be a right angle right here. And then all I have to do is find the complement of 51 and make sure that these two add up to 90. And that would be, what is that? 50, 80, 40, 40, 39, 39 degrees. Okay, seems pretty simple. Seems pretty simple to start. Now, a little bit of a twist on this. Something really, really cool about this is they're going to be asking you questions, application questions. So let's say that you are on like the Earth, okay? And you're in a tower on the Earth that's like 100 meters tall. 100 meters tall, okay? And if that's 100 meters tall, then we got to know how far on the Earth we're going to see. Now, we're going to assume that the Earth is a sphere, which it's almost there. But if you were to extend this line right here and make it seem like, here's my line of sight. Now, this is not to scale, obviously. Here's my line of sight. We would actually need to know what the radius of the Earth is. So the radius of the Earth is approximately 6,400 kilometers. Now we could do a couple things here. We could convert, since that's 100 meters. 100 meters is 0.1 kilometer. That's right? Boom, boom, boom. Yep. So 100 meters is 0.1 kilometers. So that means this line right here, this line segment will be 6,400. This whole entire segment from here to here will be 6,400.1. Okay, 6,400.1. Let me get rid of that. 6,400.1. So now I've got this hypotenuse right there, and I'm trying to figure out, now obviously this is way not to scale because this is going to be like super tiny little sliver here. But I need to find out what this distance that I could see if I'm only up 100 meters. So I'm going to use Pythagorean theorem. Okay, I'll write it out first. So I'm going to go 6,400 squared plus d squared equals 6,400.1 squared. And use my old calculator, and I'm going to go 0.1 squared minus 6,400 squared, and this is super small, 1280, and I'm going to square root that, of course, because we're using Pythagorean theorem, and it turns out that d is 35.777 non-repeating decimal. So I've got about 35 meters, almost 36 meters we can see if I go up 100 meters. Okay, so the cool thing about this is we're looking at these questions, we're trying to see which different ways that we can go and how far we can see it, and how far we can we use a sort of like a Pythagorean theorem to help us with these real life type questions. Okay, one more type of thing I wanted to show you was they're going to give you a question that's something like, hey, here's a nice right triangle, although that's not a good picture. There we go. Here's a nice right triangle, something like this. And this is x, and this is x, and this is like 12, and this is like 8. Just this part right here is 8, and they say solve for x. Now, the cool thing about this is you can think about, oh, I know my Pythagorean triples, I know what's going on. But if you think about the Pythagorean theorem, you know that x squared, and that's going to be a tangent, so it's going to be a right angle, plus 12 squared should equal x plus 8 squared. Now, we're going to do some Pythagorean theorem here, and you don't have to remember how to factor for this because these are going to cancel out in a second. X squared plus 144 equals x squared plus. Now we got to be careful how we FOIL this out. Remember, quantity squared means x plus 8, x plus 8. So you've got the first, which is x squared. You got your outer, which is 8x. You get your inner, which is also 8x. You guys might do the box method instead. And then you got that last plus 64. So right now the x squareds cancel out on both sides, but 144 equals 16x's plus 64. And now if I subtract 64 off both sides, I've got 80, and 80 divided by 16 is 5. And then you go back up here, you're like, wait, is that actually right? Oh, look, it's good old 5, 12, 13. What do you know? So there's it in a nutshell for today. Tangents are perpendicular. That's all we really got to know. And we're going to use that with right triangles. We're going to use that with situational problems. And we're going to use that with a little bit trickier ones as well. But even just as simple as find the angle right there. So that should be pretty good. Go on to your site and find the worksheet. And I hope you guys are having a great week. And we're starting out really great. I hope that your time at home is good. And we're starting chapter 12, which is kind of exciting. This is our last chapter together. It's all about circles. So way to go. You guys are the best. And hang in there and enjoy tangents. Goodbye.